In this section, we're going to look at techniques we can use, strategies we can use to collect data and conduct experiments in a way that makes our results reliable and universally accepted. So let's look at just in general, if we're wanting to do some sort of study on a population, what does that process look like? Start off with identifying what is the variable about a population that we're interested in, right? The variable would be any point of interest. Maybe we want to do a study on the most effective way to quit smoking, or dietary changes that make differences in obesity rates within populations. So those would all be variables: smoking or quitting smoking, diet. These are the variables. So you can think of a variable as something that will vary from person to person or thing to thing within the population. So once we've identified the variable, and then we want to look at what's our target population. Population can be a group of people or things within. They can be large and they can be small. So they don't necessarily have to be people or animals, but they can be things or behaviors, etc. Number two, we're going to develop a detailed plan for collecting data. And this is more difficult than it sounds, because depending on the situation, there could be a very large population that we're targeting. If we're targeting, say, the city of Tacoma, that's hundreds of thousands of people. So then we have to say, okay, we're not going to be able to talk to everybody here. We're going to take a sample, and we want that sample to be representative of the population. How do we do that so that we collect a sample that is not biased, that we're not putting together for our own ends, either consciously or unconsciously? Once we've done that, and we're going to look at ways to do that, then we actually will collect our data. And once we've collected it, we begin to analyze it. We look at numbers and graphs and organizing it, categorizing it, etc., which we'll also be looking at. And then we're going to interpret that data and see what that data tells us about the underlying population that we randomly selected it from. And then we're going to identify any possible errors that existed. So let's look at data collection. There's really two ways for us to collect data. And the first type of, and sometimes the variable that we're looking at also kind of dictates what we're going to do. An observational study is something where we are trying to collect data that already exists within a population. We're trying to observe and measure characteristics of interest to us as a part of the population. So the key thing to remember with observational data is we are just observing and trying to collect. We're not interfering with that population. We're just trying to collect. So if we're asking questions, let's say we're doing an opinion survey, we have to find out ways to make sure that we are not, as we try to collect this data, moving them in one direction or the other, or answering questions in such a way that might spur certain responses. So these are all things we have to look at as we're trying to collect data that already exists. The key thing with an observational study is that the data exists. We just need to figure out how to collect it. So sometimes those are opinions. Sometimes those are measurements. Doesn't really matter. We just need to try to find a way to collect that data. So, for example, researchers measured the amount of time people spent doing various activities such as paid work, childcare, and socializing. Okay. Observational studies stand in contrast to experimental data. In experimental data, we actually actively interfere with our sample from the population. So usually we're trying to, whereas with observational studies, we're trying to observe data, collect data that already exists. In an experiment, we're trying to create data that did not exist before. This could be a testing of a new drug or vaccine for a population. So in an experiment, we are actively interfering. We are actively giving a treatment. Usually there's one specific thing that we're trying to put or apply to our population. So whether that's a pill, whether that's a teaching methodology, whether that's a behavioral measurement, there's lots of different ways that we can apply a treatment to a population. And so we call the group that receives the treatment our treatment group. And we see how our population responds to that treatment. With a treatment being applied to a group, it's also important for us to actively have another group who is not receiving a treatment. So the part of the population that is not receiving the treatment is called our control group. So that's kind of our neutral population. It's the one that we're going to compare our treatment group to. To the controlled group, no treatment is applied. The subjects in both groups are called experimental units. Okay, or subjects, sometimes is how they're just referred to. Now, with that control group, many times the control group will receive something called a placebo, which allows the participant to believe that he or she or it is receiving a treatment. But the treatment is like just giving them a sugar pill, right? There's nothing real to it. It's just something so that, at least in their mind, they are also a part of the treatment of the treatment group. And this is done because placebos, a lot of time we have in science called the placebo effect, where people will actually physically report that they're getting better, even if they're not, just because they think they're getting a treatment. And it's a real thing. And so we have to sometimes, and sometimes it's not possible to give a placebo to our control group, but other times it is. And so the placebo is there as a way to provide a contrast for us. So we can look at the results of our control group and our treatment group and see if we can measure any differences, any significant differences between them that we can attribute to the treatment. So as an example here, an experiment is performed in which overweight subjects are given the artificial sweetener sucralose to drink while a control group drinks water. After performing a glucose test, researchers conclude the sucralose affects the glycemic and insulin responses in overweight people who do not normally consume artificial sweeteners. So here we have definitely experiment. Notice that we are introducing something to this population. We're not just collecting information. We're actually giving them something here. We have our control group, which is given water. And then we have the treatment group, which is given the artificial sweeteners. So our treatment in this case is the artificial sweeteners. And we're trying to measure its effect on the glycemic levels. And so the control group drinking water, would we consider that a placebo? That's hard to determine there. I'm not really sure if you can say that's a placebo. But they do just want to compare the glucose levels between the two different groups to see if the sucralose affected the glycemic. So maybe if they were going to do this in a different way, where the control group was actually a treatment group, is receiving a placebo, they might actually give that group sugar water, so with actual sugar. And then they compare the two groups and see if there's a difference in their glycemic and insulin responses. Then, neither group would know whether they're receiving the actual treatment, which would be the sucralose, or they're just getting regular sugar. All right, well, let's see if we can figure out whether a given study is an observational study or if it's an experiment. Researchers studied the effect of vitamin D3 supplementation among patients with antibody deficiency or frequent respiratory tract infections. 70 patients received 4,000 IU of vitamin D3 daily for a year. Another group of 70 patients receive a placebo daily for 1 year. All right, well, this definitely would be in the experiment. We are introducing the vitamin D3, and then we're giving another group of people, the 70 patients, a placebo. Notice that they don't necessarily have to be the same number of people, as long as our control group and our treatment group are large enough where we couldn't make the argument that, there's something about these 70 people or whatever that made their results unreliable. Like maybe they were all female or they were all male or who knows. So you just want to make sure that you have enough to show repetition of the results. All right, another example. Researchers conduct a study to determine how confident Americans are in the economy. Researchers call 3,040 U.S. adults and ask them to rate current U.S. economic conditions and whether the economy is getting better or worse. All right, so this is an example of an observational study. There's people out there have opinions, right? And so our goal as researchers is simply to collect those opinions and to not interfere with the patients at all. Now, sometimes you might more or less say that you're trying to lessen or minimize the amount of interference, because whenever we interact with a group, there's always an amount of influence or something that occurs there. But we're just trying to do to our best abilities and collect the information without interfering or changing the conditions. Another more modern way that we've been able to use data or to collect data is through simulations. This is definitely a more modern thing because a lot of times it uses involves the use of computers. And in a simulation, we use mathematical or physical model to reproduce the conditions of a situation or process. So since black holes, for example, are so far away from us, it's difficult for us at this distance and with time and all that, we don't necessarily have the time, but we could use mathematical models and computers to simulate the gravitational rotation of objects, etc. And in fact, it was the use of simulations and things like that that helped us to photograph the first black hole just a few years ago. So this just allows us to study situations, to collect data which are just physically impractical or sometimes are even dangerous to create in real life. And also it saves us time probably being the biggest thing, and money. For example, we can do simulations with dummies to study the effects of crashes on humans. So these are other ways that we can create and collect data. Another way is to do a survey. Of course, surveys are used for observational studies. An investigation of one or more characteristics within a population. Surveys are carried out on people, generally, by asking them questions, commonly done by interview, internet, phone, or mail. And in designing a survey, it's important to word the questions so they do not lead to biased results, which are not representative of the population. There's lots of ways that questions are sometimes asked that can influence the way that people answer them. And sometimes they influence them in ways that will contradict each other. On the issue of abortion, for example, if you ask a generalized population about do you believe, these are actual situations, but like, do you believe that women have the right to choose. And then you'll get a certain response. Maybe it's 56% of a given population. But then you take that same population and you ask, should the fetus be considered a child? And you'll get also a response that's in a majority position. So those are ways that we word things that the way they're worded can sometimes have an influence on the way people will answer them. And so we have to try to be as unbiased as possible and make sure we're not making an argument within the question itself. If we are designing an experience, this is a little more in-depth than just doing an observational study. We have to introduce some controls into our groups because we want to control for variables that we may not think about. We don't want to be able to say, oh, well, the reason this experiment turned out the way it did wasn't because of what you were actually measuring, but it was because of this other variable that you didn't account for in the design of your experiment. So there's three key things that we have to have when we're setting up an experiment. Number one, we have to have controls. So this is what makes experiments more expensive and more difficult. If we don't have controls, then we really are not going to be able to trust in our results, right? Generally, there is one variable that we're looking to measure, maybe two, but generally it's one or two. And so we need to account for that other possible variables that might be out there. We want to control for those so that they're not having an impact on the result. Also, randomization. If we're breaking people into groups, we don't want to leave the grouping of the people of our samples up to somebody. We want it to be left up to some random process. So they need to be randomly selected and then randomly put into various groups, whether they're put into the control group or the treatment group, etc. And then third, replication. The results of an experiment always need to be replicated in order for them to be reliable. Replication really ties into sample size, how many people are a part of the experiment. Does this carry on to, does this not matter when we did it or to whom we did it? Are the results similar every single time? So they have to be able to be replicated. If you can't replicate the results in almost every group situation, then you begin to call into question whether your variable really is the cause or whether the treatment is effective. One of the things that we want to watch out for, and this is why controls are put into place, is when we have hidden variables, which we might call, or they're sometimes called confounding variables. You can think of confounding as like interfering. So we have these sort of hidden interfering variables that are really the cause behind the results that we're seeing. So if we as an experimenter can't tell the difference between the effects of one variable over here versus the other variable over here, we say they're confounding each other. We can't separate them and say, oh, it's this variable that's really the reason. For example, a coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If business at the coffee shop increases, it cannot be determined whether it's because of the remodeling that she did or if it's the fact that more people are being drawn to that area because of the new mall, right? We really can't say, oh, it was the remodel. Well, are you sure it was a remodel? You were all the way over by yourself over here, but now there's a new mall, so people are over in that area, so maybe that's the real reason people are starting to come to your coffee shop. So you can see there that because of those variables not being able to be separated out, not being able to say, well, these people came because of the remodel, these people came because of the mall. It's very difficult for us to tell whether it was the remodel or the mall that was the cause behind the increase. We mentioned earlier that a placebo effect is a real thing. It is. It occurs when a subject reacts favorably to a placebo when, in fact, the subject has just been given a fake treatment. So that can take on many different looks. So one of the techniques that we can use to help control or minimize this placebo effect is called blinding. And there's really two levels of blinding. We have blinding is where the subject, the person who's a part of the experiment, does not know whether he or she is receiving the treatment or a placebo. So that's one level of blinding. And then we have double blinding, which in a double blind situation, neither the subject nor the experimenter, the person who is interacting directly with the subjects, knows if the subject has received the treatment or a placebo. So if there is a doctor who's evaluating the effects of a treatment, it's helpful to have that doctor, especially if he or she has a vested interest in the success of the treatment, it's best that they don't know who's receiving or not receiving the placebo, because sometimes even unconsciously we can want something to work or be effective so much because our financial interests are tied up into it that we overlook things, or we're not careful in the way that we interact with the subjects. One of the most important things, whether we're doing an observational study or whether we're doing an experiment, is randomness. When we're selecting a sample from a population, if it's not random, the results will not be able to be trusted. So when something is randomized, we have a process in place that assigns subjects to different treatment groups. This is, of course, in an experiment setting. But in an experiment, once you have your subjects, so they're people of things that are going to be a part of the experiment, we don't decide personally. We don't let people decide. We put a process in place that chooses where people go. And they'll be assigned to different treatment groups through random selection. And sometimes we'll divide subjects with similar characteristics into blocks. And then within those blocks, so in other words, we might divide them up by gender. We might divide them up by age. We might divide them up by region. And then within those blocks, we will randomly assign subjects to control and to treatment groups. So for example, we might have all of our subjects here, and then we might divide them by age. And then so when we divide them by age, that's not really random, right? That's just, we have to select the treatment groups, but once we've selected them, it's determined where these people are going to go, right? So we didn't use randomness at that level, but at this level, we randomly put them into control and to treatment groups, even after we've separated them by age. Now, why would we separate them by age? Maybe we also want to see if age is a variable or a factor in the outcomes that we see as well. Are different people at different ages more responsive to a treatment? And so we might be wanting to look at that as a variable within our experiment as well. In a matched pairs design, we either have the same subjects who would be, we have subjects paired up because they have some similarity. Maybe they're within the same age group, or maybe they're in the same gender, or maybe they're the same person. Sometimes in a matched pairs design, we have the same people. We'll apply one treatment to them, see how they react. We'll apply a different treatment to them and see how they react. So it doesn't even have to be different people or different things. It can be the same thing, but we compare their reactions to different treatments. The thing is that they have to be fairly similar. And so one of the things that one group of people that are used a lot of times are identical twins because they have the same genetic makeup. And so we'll be able to compare their two reactions to something similar, see if they react to it in different ways. Another example might, if we were looking at someone's reaction to alcohol in their driving, here's where we could use the same person. With different people, it's hard to pair up people who are similar in their driving. All of us are kind of different, not to mention if our reactions to alcohol. So if we have one person do an obstacle course while they're sober, then give them some alcohol, and then have them do the same obstacle course, and we compare their reaction times, we can compare two different numbers, right? Some sort of like reaction time numbers that are similar. It's the same person, the same driving skills, everything. And so a lot of times in a matched pair design, we're actually looking at the same person, but with two different treatments. As we said, sample size is a big deal. And when we talk about sample size, simply that's just the number of people that we have in our study, whether it's an experiment or whether it's in an observational study. And one of the reasons why it's important, especially in an experimental subject, is it really has to do with the repetition part. The replication of our results needs to be consistent. And so the bigger group that we have, the more reliable our results are. Now, it doesn't mean we have to have huge numbers of people to collect any kind of data about some sort of variable. But the more we have, the easier it is, or the more reliable it is. To test a vaccine against a strain of influenza, 10,000 people are given the vaccine and another 10,000 are given a placebo. Because the sample size, the effectiveness of the vaccine would most likely be observed. So then, again, very large groups of people. We want to make sure that this vaccine that we're testing is effective. We can't just say it's effective, right? In science, we have to show it's effective. And so when a company makes a claim about the effectiveness of their drug, they have to publish all the ways in which that drug was tested so that other people can criticize or take apart any of the problems that they might have had in setting that up. Obviously, the company itself has a vested interest, right, in the success of that drug. And so to determine how successful it is and to get buy-in, they need to be transparent about how it was tested. And so these are very established scientific processes, and it's not just somebody's opinion that's given. These are tested, they're experimented with, and it's important to have these because we want to make sure that what we're taking or what we're doing is actually going to have an effect on the variable. So here's an example. A company wants to test the effectiveness of a new gum developed to help quit people smoking. Identify a potential problem with the given experimental design and suggest a way to improve it. All right, so the company identifies 10 adults who are heavy smokers. 5 of them are given the new gum, and the other 5 are given a placebo. After 2 months, the subjects are evaluated and found that the 5 subjects using the new gum have quit smoking. So think about this for a second. Maybe you want to pause the video and think about what is a potential problem here in the way that this was set up. All right, so hopefully you notice just the sample size here that we used. The sample size of 10 people, that's not really big enough to validate the results of the experiment. So we need more replication to see the effectiveness of this drug. So 10 people might be a good starting point, right? We might be able to use this to say, hey, we need more funding. We might be onto something here. Can you give us more funding to do a bigger study? Okay, maybe that could be used to convince somebody of that, but 10 people would not be enough to put something out there into the market if it's only been tested on 10 people. So here we go. A company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify a potential problem. All right. So the company identifies 1,000 adults who are heavy smokers. So, okay, we fixed that problem. The subjects are divided into blocks according to gender. After 2 months, the female group has a significant number of subjects who have quit smoking. So the problem here is we divided the groups by gender, and so that could be problematic. We don't know that the effect of gender would be on this chewing gum. It's possible that maybe it has a greater effect on women than men. Rather than divide them by gender, though, we should really just divide them into a treatment group or control group. Gender probably is not going to play a role here. We just need to find out, is this gum effective? And so we need to put them into a treatment group and then also into a control group that's large enough so we can compare the results. All right, let's look at some sampling techniques that we can use. Now, you may remember it was a couple years ago that we carried out, it was actually in the year 2000, but it was difficult because of the pandemic. It might have been extended to 2021. But regardless, fairly recently, we did a census, which is done every 10 years in the U.S. And the census is an attempt to count or measure an entire population. And usually if I was in the classroom right now, I'd say, all right, how many here participated in the census that we did 2 years ago? And usually I see about 3 or 4 hands out of 30 go up, which is never a good sign, right? So a census is a countermeasure of an entire population. Of course, it's very difficult to do. So usually they have to do some extrapolating from these results. But the attempt is to get everybody involved. A sample is a countermeasure of part of a population. It's more commonly used in statistical studies. I want to point out there actually was a push some years back to, instead of trying to do a census, to actually do targeted sampling as a way of doing the census. And really, I guess the argument there was, look, we're not really doing a census anyway, right? The census, it doesn't reach everyone. There's so many people, as much as we try, that will not respond or won't participate. So they have to send an army of people out there to try to get them to participate. And really, we actually, ironically, could get more accurate results by acknowledging the reality that the census is almost impossible to conduct, and instead do targeted sampling, which really that's what we end up doing anyway, right? Because we can't reach everyone. And so it's more of an acknowledgement of the fact that we can't reach everyone. Targeted sampling is ironically more effective and can actually give us more accurate results. Even with the best methods of sampling, a sampling error may occur. A sampling error is a difference between the results of the results of a sample and those of the population. Yeah, so sampling error just means we didn't get a good sample. And so our sample really isn't representative of the population. And if there's an error involved, it's that difference between our sample and the population actually also made a difference in the results of that study. And so it's very difficult for us to tell when we do and when we do not have sampling errors occurring. What we have to look at is the techniques that were put into place, the controls that were put into place, and sometimes we can make an argument that there may be a problem with the sample in this case. But those are very difficult to nail down. The general idea is, here's our population, and we want to get a smaller group from that looks like and is representative of that larger population. So how do we get a random sample? This is really the key. A typical simple random sample should look like the general population, and every possible simple random sample should be similar in its results And so that's kind of an ideal that we shoot for. But how do you get a random sample truly? And how do you get people to participate in that sample? You know, when you get down to the brass tacks of it, it's not as easy as just saying, well, I'm just going to go collect a random sample. So what are some techniques we can use? Well, when we talk about simple random sample, this is just the basic, kind of a very idealized version of collecting a sample. But think of it like names in a hat, right? We've all done these type of things where everybody puts their name in a hat and we select a random sample, right? And as long as we mix it up all right and we all folded the papers the right way, we kind of assume that that's a fair way of picking a winner, or in the case of creating a group, picking a random sample. In a more sophisticated way, we can't really put names in a hat, but we can assign people random numbers and then have a calculator or computer generate a bunch of random numbers. So that's how we can at least begin an idea of a simple random sample. The problem also, just as logistically, how do we contact those people? Will they participate? How do we incentivize them to participate? And so it's not as easy as that sounds. And there's a lot of challenges that we run into. Now, let me ask you this, something I want you to think about. Let's say I do collect a genuinely simple random sample of 1,000 people from a population. And my question is, if males and females are divided up roughly 50%, 50%, how do you is our random sample going to contain exactly 500 females and 500 males? Right, there's a question. The answer is probably, if we ended up with those exactly 500 males and 500 females, we'd almost be surprised if that was the case, right? If it was like exactly 500. Now, if we had 53 to 47% male to female, female to male, we'd be like, okay, that seems pretty good, right? Actually, that would be really good. Or maybe it's like 51-49. But to get exactly 50-50, we'd actually be surprised if that happens, right? Now, the population as a whole probably is pretty close to that 50-50 spread. So the idea here is that, of course, when we take random samples from a population, we don't expect it to be exactly the same. We just kind of expect it to be close. And that's generally what we're shooting for. Now, if those particular divisions were super important to the idea of my study, I may want to be a little more systematic in the way that I'm collecting my sample. And that leads us to some more techniques that we can use beyond just saying, I'm just going to assign everybody a random number and generate a sample. If we want to make sure that we have equal representation of male and female, then we may want to set it up that way. This leads us to a stratified sample. This is the first techniques, where here we actually divide our population into the groups that we know exist, right? And it's totally up to the people who are doing the sampling of how they want to group up the population. Maybe it's by age, maybe it's by race, maybe it's by socioeconomic status, maybe it's by gender. However and whatever is important to the study, they divide the population into those groups. So with my male-female example there, we can say, hey, I literally want half of my population or half of my sample to be male and half of it to be female. And I know I'm not going to get that exactly when I do a simple random sample. I just want to ensure that from the beginning, so it's not something I even have to worry about, because it's important for the study. Maybe we're studying opinions on women's issues, and so we want to make sure we have equal balance between the sexes. All right, so here's where we divide our groups into strata, but then from those groups, from those what we call strata, we collect random samples. So to collect stratified sample of the number of people who live in West Ridge County households, you could divide the households into socioeconomic levels and then randomly select households from each level. So you see we've created these 3 different groups, and then we randomly select households within those groups. That's called a stratified sample. Not to be confused with the next one, which is a cluster sample. In a cluster sample, we divide our population into groups, but those groups are not necessarily by any kind of inherent characteristic that was separate, like male and female. Really, they might just be reachable groups. For example, if we take our region, we say, well, we want to do a poll on something in the Tacoma area. How do you feel about the garbage service? Okay, which personally I'm very divided on that because I don't like the other week situation. Because if you miss a week, then you're really messed up when now you have to wait 4 weeks to have your garbage collected. Anyway, not to go. So let's say we were going to do a survey on that. So it's impossible for me to talk to everybody within the city. But then let's divide it up by voting counties. I'm trying to remember what those are called. But and so maybe by the zip codes within there. And then, well, let's divide it up further. Let's divide it up by streets, right? And so, because even within those zones, inside, let's say, those zip codes, how am I going to reach those people? Where do I start? Where do I start with the sampling? Well, in a cluster sample, I like to call cluster samples like targeted censuses. Because what we do is we put them into small enough clusters where we can reach out to everybody and do sort of a census within those clusters. And so in a cluster sample, we divide them up into kind of regions or reachable groups, and then we do a census within randomly selected clusters. Not all of them, but just randomly selected ones. And we do enough of those regional or group censuses, right? A census means we collect everybody from that or attempt to collect information from everybody within those groups. We're kind of doing a targeted census. We're getting it down to a smaller, reachable group from which we randomly select those groups. We randomly select those clusters and then go after everyone who is in those clusters. Another sampling technique is a systematic sample. We start at a random value, and then we choose every kth member from the population from that starting point. So in the West Ridge County, you could assign different numbers to every household, and then randomly choose a starting number, and then start from there, go with every 100th one after that. So if we start at the 86th one that we randomly select, we could go to every 100 after that. Each of those being a part of my sample. This type of random sampling is a lot of times done for quality checks on in factories, right? If they have factories, they might choose every 100th item for a quality check. So these are a lot of times used in those situations. The last one is something that we actually try to avoid. So we mentioned something that's like, don't do this one. But because this tends to be a problem within people when they set up a sample. For example, if we have you guys do some sort of data collection, a lot of times a convenience sample will mess up the results. And this is just by choosing members of a population that are easiest for you to reach. So in a sense, what you're doing is you're collecting a sample not based on some sort of outside methodology, but you're just choosing that example or that sample because they're the easiest people for you to talk to, and you just want to get it done, right? And not to say anything against you, that just is a human condition, right? So a lot of times when we do a convenience sample, we only go after those people who are easiest for us to reach. If they're not a large enough group and they're too connected to us, we might end up collecting opinions, especially if we're talking about opinions. We tend to group together with people who have similar opinions to us. So you can see where there might be problems there. So here's some examples of how we might do some sampling, and I want you to try to identify what's the technique that we're using. So we divide the student population with respect to majors, and then randomly select and question some students in each major that we've divided it into. So what kind of sampling technique is that? For that particular sampling technique, this would be the stratified technique. We've divided them into groups. Basically, the majors are the groups, and then we're randomly selecting from each of those groups. That's a stratified sample there. Number 2, you assign each student a number and generate random numbers. You then question each student whose number has been randomly selected. This would be a simple random sample. As you guys know that, because those are basically, that's basically the definition. Is we assign the numbers and we generate random numbers. All right, number 3, you select students who are in your biology class. Okay, well, this would be a convenience sample. Now, depending on what it is you're trying to ask and what the consequences are for the results, this would not be a very scientific design at all. It's too convenient. And so we would want to avoid that type of setup there most of the time. Number 4, we select 6 classrooms at random and survey all the students in those classrooms. So out of all the classrooms on campus, we select 6 of them, and then we administer a survey to all the students in those classrooms. This is the cluster sample. We divided them into groups, and then we randomly chose groups and targeted everybody within those groups. So it's a targeted census, in a sense. Last one, you start at the lowest floor and survey every 5th classroom, starting with the randomly selected classroom on the lowest floor, working your way up to the 3rd level of the building. All right, this would be our systematic sample. We are choosing every 5th classroom, starting at a random spot, and then we're working our way through the whole building. So by definition, that's just a systematic sample. And that is the end of this lecture. So hopefully you're getting a picture of the ways in which we can collect data from a population in reliable ways, some of the strategies we use, and some of the principles we follow in making sure our sample is representative of our population and that the results of my experiment or observational study are reliable. If we don't have this foundation going forward, everything going forward is nil. It's not reliable, so there's no point to it, right? So this is probably one of the most foundational and important things to get right if we're doing a scientific study.